part 2 of section 7.2 on parallelograms. So by definition, a parallelogram is a quadrilateral with opposite sides that are parallel. We also know some other things about parallelograms, such as the diagonals bisect each other, opposite angles are congruent, opposite sides are congruent, and consecutive angles are supplementary. Those are all things that we have discussed in part 1. Part 2 is going to be focused only on graphing. So the first thing we're going to do, it says find the coordinates of the intersection of the diagonals of parallelogram LMNO with vertices L, M, N, and O. So first thing we're going to do is graph each point, of course labeling it on your coordinate plane. Okay, so the next thing they ask us for is the intersection of our diagonals. So the next thing I would recommend doing is taking a straight edge and going ahead and connecting each coordinate together, the diagonals together, and then we are supposed to name the point of intersection. So this one is located kind of in between the grid lines, so this is not one that I think you can name just looking at the graph. So you could probably make a guess for your x coordinate and a guess for your y coordinate, but what we want to know is we want to know exactly where they intersect at. So what you're going to want to know is you are going to want to find the midpoint, because the diagonals bisect each other, which means that has to be happening at the midpoint. So to find the midpoint, if you remember, you add your x coordinates together and divide by 2. And then you do the same thing for your y coordinates. So in this case, my x coordinates, and I'm going to pick one diagonal. I'm going to pick MO. So I'm using M's coordinates and O's coordinates. So if I want the midpoint of MO, I'm going to add my x coordinates together, which are 7 and 0. So 7 plus 0 divided by 2 is what needs to happen, which is 7 divided by 2, which is 3.5, or 3 1/2. Then I'm going to do the same thing, except for this time I'm going to use my y coordinates, which are 4 and 0. So 4 plus 0 is 4. 4 divided by 2 is 2. So the coordinates that I'm looking for, where these intersect, are the point 3.5. That's a weird looking 3. Let me try that again here. 3.5, comma 2. Now, let's suppose that I used N and L's coordinates instead of what I just did. Let's see what happens, because it doesn't matter which coordinates you pick. So if I use L and N, that would mean I would add 1 plus 6 together, which was 7. Dividing by 2, I still get 7 divided by 2, or 3.5. And then if I try the y's, 4 plus 0 divided by 2, I get the same thing. So the moral of the story is it doesn't matter which coordinate you use, you just need to pick one. So that is how you're going to find the coordinates of the diagonals where they intersect. You're going to find the actual midpoint of one of the segments. It doesn't have to be both of them. Looking at our next type of problem, this one asks me to find the coordinates of a vertice. So 3 vertices of parallelogram WXYZ are given, and we are looking for the fourth. So first of all, W is -1, -3, and X is -3, +2, and Z is +4, -4. So following the order that they give me for my parallelogram up here, it says that W has to connect to X, connects to Y, connects to Z. So what that means is, in order, W goes to X. X then has to go somewhere over here, because then it's going to get matched up with Z, and then it has to swing back around to W. So that means that my point that I'm looking for has to be somewhere in the first quadrant. So what we need to do to go about finding this, now we already know Z is going to connect to W. I should make that point known. we know that Z has to connect to W. So we actually know these two purple segments here exist. We're looking for this other one. So we know approximately where it has to be. So this has to do with slope. So what we need to know is we need to either know the slope of XW or we need to know the slope of WZ. And it doesn't matter which one. So if I find the slope of WZ, that would be going down 1, and then I would be coming over 1, 2, 3, 4, 5. So my slope is going to be negative 1/5. That side has to be parallel to whatever side is coming off of X. So from X, I'm going to use my slope of down 1, right 1, 2, 3, 4, 5. And that's going to locate the point where I need it to be. So this should be the coordinates of Y. However, I'm going to go ahead and connect and verify that it looks like a parallelogram, and it does. So my coordinates for Y are 2, 1. Now I should say, if you went ahead and found the slope of XW, that would be coming down 1, 2, 3, 4, 5, and to the right 2. So that slope would be negative 5/2. But I wouldn't start with X in that case. In that case, I would have to start down here at Z. And if I go down 5 and right 2, that's going the wrong direction. So I would need to go up 1, 2, 3, 4, 5, left 2, and I'm landing right on top of my Y. So you can work with that either way. Let's do another one of those. So this one gives me 3 vertices of parallelogram. D, E, F, G, and we're supposed to find again the 4th vertice. So D is the point -1, +4, E is the point 2, 3, F is the point 4, -2, and we are looking for G. So once again, I'm going to look at the order in which they present that information to me. So I'm going to go ahead and connect it in the order they're saying. So D has to go to E, so I'm going to connect those. E has to go to F, so I'm going to go ahead and make a connection there. Now from there, we know that F has to go to some coordinate G. We just don't know where G is. So it has to be this direction from F to make it to be a parallelogram. So what we need to do is we either need to find DE slope or EF slope. So I'm going to go ahead and find DE slope. Rise over run would be -1/3. So that means from starting at F, if I go down 1, right 3, I end up off my graph. So I need to go up 1 and left 3, the exact opposite direction. That is going to be my coordinate for G. And then I'm going to go ahead and make the last connections and name the point G. So G should be the coordinate 1, -1. So kind of opposite idea here. If I had found EF's slope, let's see here, rise would be 1, 2, 3, 4, 5. It would be a -5/2, and I would have gone from point D and gone down 1, 2, 3, 4, 5, right 2, and I land right on top of G. So both of them take you to the same point. So 2 graphing problems, 2 different sets of problems dealing with part 2 of section 7-2.